The circuit consists of a bulb, capacitor, DC source, and a switch. When the switch is on, the bulb glows for a moment. Circuit consists of capacitor, bulb, AC source. When the switch is on, the bulb glows forever. So, what is the reason? Watch the video. Capacitor consists of plates P1 and P2. Consider two circular loops C1 and C2. C1 is outside the capacitor and C2 is inside the capacitor. R and P are points on C1 and C2. By Ampere's circuital law, closed line integral B dot dl is equal to mu 0 I. Then magnetic field due to current at R is B times 2 pi R is equal to mu 0 I. Therefore, B is equal to mu 0 I by 2 pi R. Magnetic field due to current at Q is B into 2 pi R is equal to 0 since current is 0. Therefore, magnetic field B is equal to 0. But when we place a compass near the capacitor, it will deflect. So there exists an inconsistency. So inside the capacitor, there is no conduction current. Conduction current is only outside the capacitor. Inside, there is no conduction current. So this inconsistency, that is, inside magnetic field is 0. So this inconsistency cleared by Maxwell. So by Maxwell, E is equal to sigma by epsilon 0. This is the electric field inside the capacitor. So then sigma is the surface charge density. By substituting sigma is equal to Q by A, we get E is equal to Q by epsilon 0 A. Then the flux through the surface C2 is phi is equal to E dot A is equal to EA cos 0. Here the electric field and area vector are parallel, so theta is 0. Then again we substitute the value of electric field E is equal to Q by epsilon 0 A in the equation. We get phi is equal to Q by epsilon 0. The rate of change of flux is d phi E by dt is equal to 1 by epsilon 0 dq by dt. Here phi is the electric flux. So d phi E by dt is the rate of change of electric flux. Therefore, rearranging the equation, we get dq by dt is equal to epsilon 0 d phi E by dt, or dq by dt is id. That is the dq by dt is the current. So id is equal to epsilon 0 d phi E by dt, where id is called the displacement current. So inside the capacitor, id exists, and outside the capacitor, conduction current IC exists. So id is the displacement current. It is due to the rate of change of electric flux. So IC is the conduction current. So displacement current, the definition for displacement current is that current which comes into play in a region in which electric flux is changing with time. So whenever electric flux changing with time, displacement current is developed. So this is the reason for the bulb glow continuously when an AC is applied to a circuit. Maxwell modified Ampere's law to the form closed line integral B dot dl is equal to mu 0 times IC plus ID, where IC is the conduction current and ID is the displacement current. This is called Ampere Maxwell law.